So year 13s, I believe you're actually in a classroom today and you can follow my videos in real time, to use that phrase. So we're going to be looking at the Octet Rule today. And can I just say before we start, I'm really impressed at how most of you have been keeping up with the work. You know, your homework is good. So something, thankfully, it looks like we are, despite my not being there and some of you not being there, it looks like we're making some progress. So just keep working. For those of you who aren't working, can you please get in touch with me? I will be sending you an email. I worry about you. I'm not going to come down hard on you, but it's really important that you get some kind of routine in place to get some work done. This is not going to be a good winter in terms of schools and everything. Okay, so, but the key thing is to get you through to the other end of all this, and at least by the time you go to university and so on, all this will be over, right? So back to the fun chemistry. So we've got, just to talk about what you've done so far, right? So you did ionic bonding, very good, hopefully, and covalent bonding, and just to remember that you need to know definitions of covalent bonds. It's slightly changed from GCSE. It talks about electrostatic attraction between the shared electron pair and the nuclei. So that's a change from GCSE. The idea of a lone pair, right? Excuse me, and the idea of bonded pairs of electrons are very important. They're going to come up over and over again. The idea of a coordinate bond, right? Just make sure you know what that is. You were practicing doing drawings and so on to include those, to show the arrow for a coordinate bond to indicate it. But ultimately, a coordinate bond is just another covalent bond. It's just really where the electrons have come from that's different, but that doesn't change the nature of the bond. It's still a covalent bond. We've done some dot and cross diagrams for molecules and ions. Now we're going to be doing more of that throughout this topic. So that's not finished. I put some feedback for you on those who handed in their homework. I did give you some feedback, just to have a look at that. And today we're going to do the Octet Rule and state its limitations. For example, BeCl2 and BF3. So if you go down, and it's on your notes, it's page, I've made mine all bigger, page 8. If you turn to page 8 of your notes, you'll see the Octet Rule there. So if we go down, right. So the Octet Rule, what is it? Okay, so you need to learn this. Now this will be familiar from GCSE. When reacting, an atom tends to gain, use, or share electrons to achieve 8 in its outer shell. That's still true for ionic bonding, I have to say. If you're doing ionic compounds, if you've and always assume that metal non-metal combinations in compounds are ionic unless told otherwise. So you'll see that BeCl2 is one of the ones that comes up here, beryllium fluoride. It is covalent, but you couldn't know that unless you're told. You would have to assume that a metal non-metal combination in a compound is ionic unless told otherwise. So just watch out for that in the beginning of questions. If they don't tell you, then it's ionic, and if they do, they'll have to tell you it's covalent. Anyway, the Octet Rule, right, is this idea of 8 electrons in the outer shell, and I know that caught some of you at the homework. Now, this is not true. The key thing is in bonding, particularly covalent bonding, is that every electron is in a pair, right? It's either in a lone pair or a bonding pair, single, double, triple covalent bond, whatever it is, but there will be no electrons hanging around on their own, okay? They're always in pairs. Now, sometimes that happens such that there will be more than 8 electrons in the valence shell, the outer shell, right? There are certain atoms, most atoms, to be honest, can have more or fewer than 8 electrons in their outer shell. So here you've got elements such as beryllium and boron don't have enough unpaired electrons to react in an octet. So beryllium will form 2 covalent bonds, boron will form 3. So beryllium will end up with 4 electrons in its outer shell when it bonds, and boron will end up with 6. That's fine, they're all paired, it's happy, right? Sorted. Okay, elements in group 5 to 7 in period 3 can form covalent compounds more than 8 electrons. Now that's most of them. So if you look in your periodic table, right, switch over to periodic table. Let's switch over. So on the periodic table, it says that phosphorus and arsenic, so in group 5, nitrogen, they're saying doesn't expand its octet, right? That it will tend to have 8 electrons. Yeah, I have to think if that's true or not. Phosphorus, right, can have 8 electrons in its outer shell, it can have more. Sulfur, so all of they're saying here that all the elements in groups 5 to 7 in period 3, right? So that's this period here, okay? And obviously sodium magnesium will not do covalent bonding ever. Almost never. I'm never going to say never again, right? So the just be aware that that's common, okay? You will see it. It's not a big deal. As long as everything electron is paired up, that's fine. Okay, so back to the notes. Right. So there's a few questions here that we'll just go through together, right? Why can elements such as beryllium and boron not fulfill the octet rule? Right, the reason is they don't have enough electrons to share, right? In order to fulfill the octet rule, you would need at least 4 electrons in the outer shell, right? Unless you had a number of coordinate bonds, which is possible. What is the maximum number of electrons that can surround chlorine in its valence shell when bonding? Well, theoretically, because chlorine has 7 electrons in its outer shell before it bonds, theoretically it could have 14 electrons. It could form 7 single covalent bonds or 7 covalent bonds with other elements, particularly fluorine, with other group 7 elements and hydrogen, right? And it could have that. Now, chlorine doesn't tend to expand to that level, mainly because it's too small. But you see that bromine can and iodine can, right? So in theory, it's 14. Dot and cross diagram for ASH5. So I want you to take a moment to do that, right? So I'll give you a minute to do that, and then I will put the answer on the board. Okay, so arsenic hydride, arsenic pentahydride, that would be okay, so arsenic has 5 electrons in its outer shell, and the same group as nitrogen. In theory, it would form 3 single covalent bonds, or 1 triple covalent bond, or 1 double, 1 single, to get 8 electrons in its outer shell. So that is not going to happen, right? So arsenic here, I've just done, I know some of you prefer to do the shells. I get it, it's very tidier looking. I'm just in my habits from the past, right? So you've got 5 single covalent bonds to hydrogens. Now, if you look here, arsenic does not obey the octet rule. Okay? In other words, it has more than 8 electrons in its outer shell. It has how many? It has 10 electrons in its outer shell. So if you're to answer questions on this, it will just ask you, as we'll see later, it'll just ask you, does such and such an atom, or to obey the octet rule, and it's either yes because it has 8 electrons in its outer shell, or it's no because it has, and you name the number of electrons that it ends up with. Okay, what about hydrogen? Out of interest, does hydrogen obey the octet rule? Well, they happily will never ask you that, but no, it doesn't, because it doesn't end up with 8 electrons in its outer shell either. So hydrogen will never obey the octet rule, for the reason that you can easily explain is that it only has an S subshell, it has one shell, can only hold 2 electrons. So it'll never obey the octet rule, but that you don't have to worry about the whole SPD notation or anything like that for this topic, right? You don't have to think about that. Okay, you really can think about it in terms of GCSE, number of electrons in the outer shell, whether they're S, P, or D or anything else isn't going to come into it. Okay, so hydrogen does not obey the octet rule. It only has 2 electrons in its outer shell. So the octet rule is specifically about 8 electrons, right? Not just a full outer shell. Just note that from the definition. Okay, so back to the notes. Draw a dotted cross diagram for SF6. Now, I'll let you do that in your own time because you actually have that for homework. But what I do want you to do is have a look at SF6 and tell me, does it obey the octet rule? So I'll just give you a moment to do that. Okay, so I've just taken a shortcut here and drawn the line, or what do they call it in that? The line, or I can't remember the other term they used. Stick diagram. Stick diagram for sulfur hexafluoride. Okay, so sulfur hexafluoride has got 6 single covalent bonds around the central sulfur atom. So is the octet rule obeyed for sulfur? No. It has 12 electrons in its outer shell. And remember that the octet rule says you must have 8. And what about fluorine? Does fluorine obey the octet rule? Well, if you look, you've got 2 electrons here, and then you've got 3 lone pairs on every fluorine, right? So you have 8 in total. So yes, it has 8 electrons in its outer shell. Now, fluorine is the most reactive nonmetal on the periodic table, right? It will force even noble gases to share electrons with it. And it will rarely, if ever, I don't think I've ever seen it with where it doesn't obey the octet rule. And that's partly because, you know, in order for fluorine to obey the octet rule here, it has to force sulfur not to. Well, don't worry too much about it. Fluorine, in fairness, anytime you have a molecule, it's only the central atom that will break the octet rule, if at all. The outer atoms will not, right? So just watch out for that. It's really only the central atom you have to worry about in terms of the octet rule being obeyed or not. Okay, so that's those questions, right? Going back to the notes. So here I've got beryllium fluoride. Now we've dealt with beryllium fluoride before, okay? And actually here I've done the one what seems to be the majority preferred. And if you notice, I've forgotten to put a couple of X's in there. So if you could lone pair of electrons in that poor bereft chlorine, that's a mistake. So could you correct that, please? Okay, so we've got here now, what I want you to say is, let's see, have a look on this and say, do the atoms in beryllium fluoride obey the octet rule? So I want you to talk about both chlorine and beryllium, and we'll come back to the answer in a moment. So the question is, I'll put it on my board. I can actually put it on here. Beryllium. Okay, someone should answer that question. Okay, so I'm just going to put the answer for you. Okay, so beryllium, no, right? Beryllium in beryllium fluoride does not obey the octet rule. It has only 4 electrons in its outer shell. Chlorine does, it has 8 electrons in its outer shell. Okay, so do the same for beryllium fluoride. It wants you to draw a dot and cross diagram or whatever representation of boron trifluoride and explain whether each atom in the compound obeys the octet rule. So can you do that now, please? I'll just give you 2-3 minutes for that. Okay, so hopefully that was enough time, right? The answer, okay, I've done, right, so boron trifluoride has that dot and cross diagram, right? Don't forget the electrons on the outer atoms. They are easy to forget, right? But they must be included or you'd lose marks in the exam. If it asks for a dot and cross diagram showing all the outer electrons, include the fluorines or the oxygens or whatever's on the outside. Okay, so in terms of obeying the octet rule, boron does not. It only has 6 electrons in its outer shell. The fluorine does because it has 8 electrons in its outer shell. Right, so your next task, go back to the notes, is if you turn over to page 9, you will see that there are some diagrams to draw there, and you have to explain whether the octet rule is obeyed in each case. Okay, so I'm going to stop the video here, I think, and because I can't pause it, unfortunately. Let me just show you what you're doing. Okay, so what I want you to do is this exercise. And I will post the answers as just as a sheet. Okay, I'll not talk through them all because actually you've done a lot of these already. Okay, so I'll give you, you probably need 5-10 minutes to do that. Okay, so thank you. I'll see you in the next video.